So no matter where you are in school, I'm going to go out on a limb and say that you're probably learning about something related to chemistry, and oftentimes one of the most difficult things to get is one of the most important, and that is periodic trends. You can understand your periodic trends, you'll be able to understand so many other concepts that you'll breeze through chemistry. Well, maybe not breeze, but at least it'll be a little bit easier. So the first thing I want to talk about today is ionization energy. Ionization energy is extremely important when it comes to atoms because it's the amount of energy it takes for an atom to lose an electron. Now we all know that electrons are negative, and negative is bad, right? So if you look on the left, you'll see a hydrogen, and hydrogens start with an H. They're happy, so they want to lose electrons. They lose them easily, and it takes a very little amount of energy because they're already so happy and they want to do it. But on the other side, when you start to get to boron, you see that boron starts with B and it's kind of bored and it's looking for some excitement. And so it wants to keep electrons around. Now, it's not just boron that likes electrons around, it's fluorine. Fluorine loves electrons more than all of the other atoms because it needs one more to complete its octet. So it holds on to electrons really, really tight so that it takes a whole lot of energy to let them go. Okay, so we were just talking about how much energy it takes for an atom to lose an electron. And if an atom really, really, really loves its electrons, it will take a lot of energy to let them go. So it makes sense that we talk about electron affinity next. Electron affinity sounds sort of like electron affection. It's how much you love your electrons. And when you move from right to left, we said that if it takes a lot of energy to remove an electron, you must really love your electrons. So it's the same here. From left to right, fluorine loves its electrons the most, and it loves to get new ones because it needs one more for a full octet. So now we're going to talk about metals and nonmetals because they're extremely important to atoms. So let's think about what's in the air we breathe. There's carbon, mostly nitrogen, and as everyone knows, oxygen. So with that, when we think about the air, it's clearly not a metal. That's probably as far away from being metal as you can be. And so when you look at the periodic table, when you go up and across from left to right, you're getting towards nonmetals. And you'll see boron, carbon, nitrogen, oxygen, fluorine, neon, and helium. So that makes sense. And then you look on the other side. So if it's not near carbon, nitrogen, and oxygen, then you're getting closer to metals. So when you go down and from right to left, you're going more towards metallic characteristics. These things are generally heavier, harder, and solid at room temperature. Okay, so we were just talking about things that were metals and nonmetals. So now we're going to talk about something really important about metals and nonmetals, and that's their size. Think about this. If you were holding a bucket full of air and a bucket full of gold, which one would be heavier? The gold, of course. So if you look at it, when you look at the periodic table, from right to left, the size of the atoms increase because they're becoming more metal. And if you have more metal, you get heavier and heavier, and it's harder to carry because it's so big. There are so many periodic trends that sometimes it can seem really confusing and dense, but don't let that stop you from loving chemistry. When you think about a periodic table, just stay calm and stop so that you can reevaluate the trends that you've learned. Remember that when you get stressed about all of these confusing periodic trends, keep in mind that fluorine loves electrons. It's like it has a lot of affection or affinity for them, and it takes a lot of energy to break that love apart, and so it has a really high ionization energy. Also remember that air is not a metal, and so if you see oxygen and carbon and nitrogen, you're where nonmetals are, as opposed to being on the other side where there are more metals. Metals are heavy and they are larger in size. So the further away you get from oxygen and carbon and nitrogen, the closer you are to metals. And remember that science, and especially chemistry, can always be fun.